Our tutorial, Multicollinearity test. Multiple regression assumptions consist of independent variables correct specification, independent variables no linear dependence, regression correct functional form, residuals no autocorrelation, residuals homoscedasticity, and residuals normality. This topic is part of multiple regression analysis with our course. Feel free to take a look at course curriculum by clicking link at description box below. This tutorial has an educational and informational purpose and doesn't constitute any type of forecasting, business, trading, or investment advice. Please read full tutorial disclaimer at the end of this video. No linear dependence or no multicollinearity consists of regression-independent variables not being highly correlated. This is evaluated through multicollinearity test, which consists of calculating an inverted correlation matrix of independent variables and assessing its main diagonal values. If main diagonal values are greater than 5 but less than 10, independent variables might be highly correlated. If main diagonal values are greater than 10, independent variables are highly correlated. Great. So let's go into RStudio so that we can study no linear dependence through multicollinearity test with greater detail. Excellent. So here we are within RStudio. In this tutorial, we'll be working within our tutorial multicollinearity test code file. And the first step is we're going to load the packages needed for the tutorial. We do so with library function and we'll be using QuantMod, MASS, and correlation plot through CORRPLOT. So we select the 3 code lines, click Run or Ctrl-Enter on the keyboard, which is equivalent. The next step is to create the data for multicollinearity test. So here we create the data object, which is equal to read.csv, and within it we have the name of the data file, multicollinearity test data, as a plain text file with .csv or comma separated values stored within the working directory, comma header equals to true. So we select that code line there, click Run or Ctrl-Enter on the keyboard, and that created a data object within the global environment as a data frame. So we click on the spreadsheet kind of icon, and this opens the data for us. So notice here that first of all we have the column with dates. Notice that dates are with a monthly frequency from the beginning of 1997 all the way to the end of 2016, therefore 10 years of data. And then we have all the columns with multiple regression variables. The first of this, stocks, that's the dependent or explained variable, and this corresponds to SPY ETF investment vehicle, which intends to replicate the Standard & Poor's 500 index, and this corresponds to its adjusted close prices arithmetic monthly returns. Adjusted close prices, which were adjusted for dividends and splits. And then we have all the independent or explanatory variables columns. And we begin with effective monthly yield of 1-year treasuries, 10-year treasury, and the high yield corporate bonds. Then we have the arithmetic monthly inflation or deflation of CPI or consumer price index, PPI producer price index, the arithmetic monthly return of oil prices. And last we have the arithmetic monthly change of industrial production index and PCE or personal consumption expenditures. So back into the code file here, we're going to convert that data into an XTS, which is an extensible time series. So we overwrite the data object, and from data, we're going to select, as we can see within brackets, all the rows, comma, from columns 2 to 10. So only the where we have data, so from stocks all the way into PC or personal consumption expenditures, and we're going to order by equals as date by selecting data, the first column where we have the dates. So we select the code line, click Run or Ctrl-Enter on the keyboard, and we can see that the data became an XTS or extensible time series, and by opening it, we see that the dates became its index. So the following step is to do the multicollinearity test. For this, we're going to create a variable named iBar in which we're only going to include independent or explanatory variables because multicollinearity test is done with only independent or explanatory variables. So from the previously created data object, we're going to select within brackets all the columns, all the rows for columns 2 to 9. So columns 2 to 9 is where we have from 1-year treasuries all the way into PCE or personal consumption expenditures. And then we're going to calculate those independent variables correlation matrix with COR function of those independent variables. Then we're going to calculate independent variables inverse correlation matrix with GIMB function of the previously calculated independent variables correlation matrix. And then we're going to rename the column names and row names of this independent variables inverse correlation matrix with the column names of the previously created independent variables variable. And the last step is we're going to visualize this within a chart, and we do so with CORRPLOT function of the independent variables inverse correlation matrix method equals to number, so we can visualize the calculations within this multicollinearity test. Is correlation equals to false because we've already done all the calculations needed, and we select these code lines here and click run or Ctrl Enter on the keyboard. So notice that we have the chart here, so we're going to zoom into it. And here we have those independent or explanatory variables inverse correlation matrix. So first of all, we have the principal diagonal here, as we can see, 1-year treasuries with 1-year treasuries, 10-year treasuries with 10-year treasuries here, all the way into PCE or personal consumption expenditures with PCE right here. So this is the principal diagonal, and as we can see within this inverse correlation matrix, we have the upper triangle mirrored by the lower triangle. So as we can see here, the value for 1-year treasuries with 10-year treasuries is the same as the one for 10-year treasuries with 1-year treasuries, and so on. That's why the upper triangle is being mirrored by the lower one. So for the multicollinearity test, we need to focus on the values of the principal diagonal right here. Excellent. So we're going to close this chart here. And now that we've finished studying multicollinearity test, let's go back into the slides. And as mentioned previously, this tutorial has an educational and informational purpose and doesn't constitute any type of forecasting, business, trading, or investment advice. Please pause the video now so you can read the full tutorial disclaimer. Okay, so with this, we finished this tutorial. Thank you for watching.